We don't come back again. Ace Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, Ace Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This is a secondary school session for out-of-school children. Hello, listeners. My name is Adesami Temitayo, and I welcome you to today's English class on ACE Radio School. Today, I will be teaching you the topic tenses. Tenses is spelled T-E-N-S-E-S. I will take that again. T-E-N-S-E-S. Tense is a form of verb that shows the time something happened or is going to happen. Tense does not really mean time, but it refers only to the verb form that shows the time of an action. There are 9 types of tenses in English. There are simple present tense, present continuous tense, present perfect tense, present perfect continuous tense, simple past tense, past continuous tense, past perfect tense, past perfect continuous tense, and future tense. We will learn the first 3 in today's lesson, which are simple present tense, present continuous tense, and present perfect tense. We'll start with the simple present tense. The simple present tense is used to express habitual actions, general truths, or statements. Habitual actions are things we do regularly. The simple present tense is usually formed by adding s or es to the end of the verb. Examples: she goes to school every week. Saliu loves sugarcane. From these examples, you can observe that the verbs goes and loves have s or es at the end. Now let us take a look at some general truths and the use of simple present tenses. It is hot during dry season. Lagos is a large city. The present continuous tense. The present continuous tense indicates an action that is still going on at the time of speaking or writing. These actions are occurring exactly at the time of speaking. The present continuous tense is formed by adding ing to the main verb. Examples of present continuous tense: the teacher is teaching now, or we can say the English teacher is teaching now. I am drinking water. It means that the action drinking water is being done exactly at this time of speaking. He is writing a letter. I am studying English at ACE Radio School. From these examples, you can observe that these sentences show that the action is being done now. The present perfect tense. The present perfect tense shows that an action which started and was completed in the past still has a link with the present. In this case, the auxiliary verb, also known as helping verbs, has and have, are used with the past participle form of the main verb. Let's take a look at some examples of the present perfect tense. She has lived in Kaduna all her life. I have worked with my father since I graduated from school. I have just finished my English assignment. Hadiza has passed the English test. You will notice the words has and have in these sentences. Alright, let us do a recap of what has been learned today. We learned that a tense is a form of verb that shows the time an action happened or is going to happen. We also studied 3 types of tenses, which are simple present tense, present continuous tense, and present perfect tense. Thank you. We learned that simple present tense usually has s or es at the end, while present continuous tense is formed by adding ing to the verb. Finally, we learned that present perfect tense usually has the words, can somebody name them? Has, and the other one is have. Very good, before the main verb in the sentence. Now it's question time. I'd like you to listen attentively to the following questions and choose the option with the correct answer. Are you ready? Let's do this. Question number 1. What tense is used to show a link between the present and the past? A. Present continuous tense. B. Present perfect tense. C. Simple present tense. I take question 1 again. What tense is used to show a link between the present and past? A. Present continuous tense. B. Present perfect tense. C. Simple present tense. Question number 2. What tense is used in this sentence? We are enjoying our English lesson. A. Present continuous tense. B. Simple present tense. C. Present perfect tense. Question 2 again. What tense is used in this sentence? We are enjoying our English lesson. A. Present continuous tense. B. Simple present tense. C. Present perfect tense. Question number 3. Which of these sentences is written in the present perfect tense? A. We have been to Canada. B. I wrote 2 letters. C. The man eats twice daily. I take question 3 again. Which of these sentences is written in the present perfect tense? A. We have been to Canada. B. I wrote 2 letters. C. The man eats twice daily. Send your responses as a text message indicating your name, gender, state and subject, that is English, to 070-363-03182. I take the number again, 070-363-03182. Alright, well done students for participating with your friends in today's English lesson. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Remember, we air primary episodes on Mondays, secondary episodes on Tuesdays, and repeat episodes on Wednesdays. Until I come your way again, it's Adesami saying bye for now.
This is an ACE charity initiative powered by Grand Force Foundation.
The secondary school session is for out-of-school children. Hello listeners, my name is Mrs. Oluwashina Teniola and I welcome you to today's mathematics class on Ace Radio School. Today, I will be teaching integers. I will explain how to use negative numbers. Get your pen and notebook and let's get ready to learn. Integers are collections of all positive numbers and negative numbers, including 0. I'll take that again. Integers are collections of all positive numbers and negative numbers, including 0. We are quite familiar with numbers from our early years. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on are known as positive numbers, while the numbers with a negative sign are negative numbers. Examples are -1, -2, -3, -4, and so on. Negative numbers always have a minus sign before the number. Let's do this activity together. Draw a straight horizontal line. Draw a straight horizontal line. A horizontal line looks like you're spreading your hands wide. Mark the center or middle point of the straight line. Put a 0 at the center of the straight line. Then label to your right hand side from 0, 1, 2, 3, 4, 5, and so on. Also label to your left hand side from 0, -1, -2, -3, -4, and -5, and so on. This line is also called the number line. I'll give you 20 seconds to do that. Tick tock, tick tock, tick tock. I believe you have done that. Excellent. Always note that positive numbers are all bigger than the negative numbers. But how do you know which negative number is greater than the other? For instance, -5 and -2. On the straight line you drew earlier, move from 0 to the left hand side. Which number did you encounter first? From 0, -1, -2. Yes, -2 came first, followed by -3, -4, then -5. Therefore, -2 is greater than -5. Wow! Also, -3 and -4 are greater than -5. Now, which of these numbers are greater, -1 or -2? Of course, -1 is greater than -2 because on the horizontal line drawn, you will encounter -1 before -2. Let's consider this example. Arrange this set of numbers from the lowest to the highest. -7, -2, -5, -4. -7, -2, -5, -4. This is very simple. The numbers are all negative numbers. You can draw the horizontal straight line, also known as the number line. Locate the middle of the line and put a 0 at the middle of the line. Now, let's label towards the left hand side. 0, -1, -2, -3, -4, -5, -6, -7. Which negative number came first? -2, followed by -4, then -5, and -7. Great! Therefore, -7, -2, -5, -4 from the highest to the lowest number is -2, -4, -5, and -7. This means -7 is the lowest of the 4 numbers, while -2 is the greatest of the 4 numbers. Quite easily done. Consider this example. Arrange this set of numbers from the highest to the lowest. -10, -18, -14, -25. -10, -18, -14, -25. This is very simple. The numbers are all negative numbers. You can draw the horizontal straight line, also known as the number line. Locate the middle of the line and put a 0 at the middle of the line. Now let's label towards the left hand side. -10, -14, -18, and -25. Which negative number came first? -10, followed by -14, then -18, and -25. Great! Therefore, -10, -18, -14, -25 from the highest to the lowest is -10, -14, -18, and -25. This means -25 is the lowest of the 4 numbers, while -10 is the greatest of the 4 numbers. Quite easily done. Consider this example. Arrange this set of numbers from the highest to the lowest. 8, minus 58, minus 19, minus 40, 77. 8 minus 58, minus 19, minus 40, 77. This is very simple. The numbers are positive and negative numbers. Positive numbers are greater than negative numbers. You can draw the horizontal straight line, also known as the number line. Locate the middle of the line and put a 0 at the middle of the line. The positive numbers will be on the right hand side and the negative numbers on the left hand side. Now let's arrange. 77, 8, minus 19, minus 40, and minus 58. 77 followed by 8, then minus 19, minus 40, and minus 58. Great. Therefore, minus 58 is the lowest of the 5 numbers, while 77 is the greatest of the 5 numbers. Quite easily done. Well done, listeners. We have come to the end of today's session. Today, we learned about integers, negative numbers. We learned that positive numbers are always greater than negative numbers. We also learned to draw the number line with positive numbers at the right and negative numbers at the left. I'd like you to try this as an assignment and send in your answers to this phone number 070-3630-3182. Type your name, age, gender. If you're a boy, type male. If you're a girl, type female, your class, and the state you currently live in. I hope you've done that. Now the questions. Arrange the set of numbers from the highest to the lowest. 1. Minus 45, minus 50, minus 44, minus 52. Minus 45, minus 50, minus 44, minus 52. Question 2. 27, minus 63, minus 40, minus 35. 27 minus 63 minus 40 minus 35. Okay, I'll be expecting your answers. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Remember that we air primary episodes on Monday, secondary episodes on Tuesdays, and repeat episodes on Wednesdays. Until next time, it's bye for now.
We don't come back again. Ace Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, Ace Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This secondary session is for out-of-school children. Hello listeners, my name is Mrs. Mosi and I am your Ace Radio School science teacher. This month we are going to be learning chemistry. You are welcome. In this lesson, we are going to be learning about the laws of chemical composition, and we will begin with the law of conservation of matter. Let us begin. Make sure you listen attentively. Have you heard of Dalton's atomic theory? Dalton, D-A-L-T-O-N. Dalton's atomic theory states that matter cannot be created nor destroyed. This theory dates back to 1789 to where Antoine Lavoisier discovered that matter can neither be created nor destroyed in a chemical reaction. I am going to explain using an example. When we burn coal, it will seem as if all the matter in the coal has been destroyed. But that is not true, because the coal is converted to ash. When you measure the coal and the ash will weigh far less than the coal. In this case, it will also seem like some matter got destroyed since they are not the exact same weight. However, we have to know that when the coal was burning, invisible products such as carbon dioxide, steam, soot, etc. were also given up. Therefore, if we add the weight of all those substances that were given up during the combustion of coal, the total mass will be almost equal to the coal before it started burning. This is because heat and light are also part of the product that is given out when coal is burnt. If it were possible to calculate the weight of the ash, the steam, the soot, and other substances that were given off while burning, the weight will be equal to that of the coal being burnt. Then we will realize that matter has not been destroyed. Einstein derived an expression for the conversion of matter and energy, which is E is equal to mc square, where E is energy, m is the mass, and c is the velocity of light. This theory is what is called the law of conservation of mass, which states that matter cannot be created nor destroyed in a chemical reaction. Next is the law of definite proportion or constant composition. This law states that chemical compound is always made up of the exact same proportion of elements by mass. I'll take it again. This law states that a chemical compound is always made up of the exact same proportion of elements by mass. For example, if a compound is made by combining 1/4 from one chemical and the remaining 3/4 from another chemical, these proportions will always hold true irrespective of the amount of chemicals added. For example, a sample of pure water contains 88.81% hydrogen and 11.19% oxygen by mass. And we all know that water can be obtained from different sources: rainwater, river water, borehole water, seawater. If this water from these sources are analyzed, we will find that water from each source contains hydrogen and oxygen in the same composition by mass. Therefore, it does not matter where the sample of water came from or how it was prepared. Its composition, like that of every other compound, is fixed. These facts can therefore be stated in the form of a law called the law of definite proportion or constant composition. Another example is salt. Salt is written as the chemical compound sodium chloride, which is made up of atoms of sodium, that's Na, and chlorine, Cl. It does not matter where the salt is obtained from. The exact same proportions of sodium and chlorine must always be combined in order to form salt. I hope you are all following me. In essence, what I've been trying to say is that if a compound is formed, the composition of that compound is going to always be the same, even if the compound is reduced. Therefore, we can also say that the law of definite proportion states that all pure samples of the same chemical compound contains the same elements combined in the same proportion by mass. Let me give an example. If 1.375 gram of cupric acid is reduced on heating in a current of hydrogen, the weight of copper remaining is 1.098 gram. In another experiment, 1.17 gram of copper is dissolved in nitric acid and the resulting copper nitrate is converted into cupric oxide. The weight of cupric oxide formed is 1.476 gram. Show that these results illustrate the law of constant proportion. In the first experiment, copper oxide was initially 1.9 grams. After heating the copper, the remaining was 1.5. So to get the oxygen present, we will have to deduct 1.5 grams from 1.9 grams. That means that the oxygen present was 0.4 grams. To get the percentage of oxygen present in the copper oxide, we will divide 0.4 by 1.9 grams, then multiply it by 100 to get 21%. I hope you all understand. In this case, the percentage of oxygen present in the cupric oxide is 21%. In the second experiment, copper oxide is 1.4 grams and the copper taken is 1.1 grams. Therefore, to get the oxygen present, we have to subtract the weight of copper from the weight of cupric oxide, which is 1.4 grams minus 1.1 gram. This will give 0.3 gram. To get the percentage of oxygen present, just as the previous example, we will divide 0.3 by 1.4 and multiply it by 100 to get 21.4%. So the percentage of oxygen is approximately the same in both the cases that we discussed above. So the law of constant composition is illustrated. We have come to the end of today's lesson. Today we learned about the laws of chemical composition. We learned the law of conservation, also known as Dalton's law, which states that matter can neither be created nor destroyed in a chemical composition. We also learned about the law of definite proportion, which states that a chemical compound is always made up of the exact same proportion of elements by mass. We will continue in our next lesson, but before we go, here is a little assignment for you to do. State Dalton's atomic theory. Send in your answers to this phone number 070-363-03182. Type your name, your age, gender. If you are a boy, type male. If you are a girl, type female. Your class, the subject, and the state you currently live in. If you can, subscribe to our Ace Radio School YouTube channel to catch up on topics you have missed. Our channel on YouTube is Ace Radio School. Bye everyone, and be sure to tune in next week. Thank you for listening.
This is an ACE charity initiative powered by Grand Force Foundation.